So thank you for the introduction, Matthias. So hello, everyone. I'm Evelina Gabasova, and I'll be talking about enabling data science research with F#. Well, first of all, this is my actual title that Matthias couldn't remember because it's relatively long. I work in the Alan Turing Institute in the UK, which is the British National Institute for Data Science and Artificial Intelligence. We are supposed to say the whole thing like this. And I work there as a research data scientist. And so first, data science, that's a big thing right now. So I decided to little cheesily punctuate my talk with hashtags. So the first one is data science. So what is even data science? Well, if you are doing any talk that mentions data science, you are required by law to include this slide. So data science is supposed to be on between computer science, mathematics, and domain knowledge. Well, I like the definition that my boss uses a bit more, which is that a data scientist is someone who's better at statistics than a programmer, and better at programming than a statistician. Which also means that quite often we feel like this. So we are sort of on a boundary between a lot of things that don't traditionally go together very well. So just to give you a slightly broader perspective, in the UK there is this broad movement to establish a research software engineer as a profession, which should give people who are interested in writing software for research like a career path that's not very traditional in academia. And I'm in a research software engineering group in the Alan Turing Institute. So what do we actually do? Well, if you are a research software engineer in academia, you are basically a professional collaborator. You collaborate with a lot of people on a lot of different things. And you care about a lot of things that are sort of this like movement right now in science towards reproducibility a lot. Because there is a crisis of reproducibility in science. This is my favorite example from cancer research. And there was a paper published that specified certain genes that were important for, I think, lung cancer. And it looked very promising, and a lot of research started based on that. But someone tried to replicate their actual research and tried to replicate their results. But they are failing. So they looked at their computational analysis, and they realized that at some point, they basically took data from an Excel table and copy and pasted it from to something else. But they didn't include headers, so all their indices were off by 1. So the results looked perfect, but when they adjusted for this, it was basically rubbish, and it didn't say anything. So reproducibility is very important. The other thing is reusability. Because a lot of academic research, you are supposed to publish everything. You usually publish the code that you write, etc. But if you look at academic GitHub, that's basically where code goes to die. Because you publish a paper, you stick it on GitHub, and you are done. So and anyone who wants to actually run the code, they will probably have a very hard time because it works on the researcher's machine with the data they have there. So we care a lot about reproducibility, reusability, and also about software development practices, which are not very traditional in academia either. I work quite a lot with R, and R, the repository for packages, library, the equivalent of NuGet in the R space is called CRAN. And they have policy for submitting packages into CRAN. And they say that submitting updates no more than once every 1 to 2 months seems appropriate. So why do anytime I open VS Code, there's a new version of Ionide. Chris, listen, you should submit updates only once or twice a month. one or 2 months. So, that's basically like a very brief summary of research software engineering and what we care about. And in the Alan Turing Institute, we are sort of experimenting of bringing data scientists into this kind of environment. So I am one of these people. So we do a lot with real-world applications of research and trying to bridge the gap between the academic research and actual real-world applications. So just as an example, next month I'm starting a big project with the National Air Traffic Control in the UK, where they want to investigate if they can use any kind of AI to actually help humans direct air traffic. But not around the airports, that's too difficult right now, but in sort of normal free space, where they are just trying to ensure that planes don't lose separation. And there's a lot of uncertainty involved in that, so, well, maybe I'll talk about this next year. But this probably falls into what people imagine under AI. But I don't really like to talk about AI because that's really an overhyped word. So I'll be talking about something else that's making the news a lot, which is fake news. That's very relevant in the UK. It's very relevant in the US as well. So right now, I'm involved in one project that's focusing on fake news. And it's about collaboration with actual social science people. Because right now, most of the research done in fake news and misinformation has been done by people who do machine learning. And sometimes these approaches are a bit naive. So we are actually collaborating with some social science people. And the goal is basically to identify fake news automatically, so that probably maybe it can make it into a browser plugin that will tell people, okay, this is fake news because of this and this. But what is even fake news? It's not news about our build system. Fake word is very overloaded in the F# space. When I will be talking about fake news, I'll be talking about actual fabricated news, about conspiracy theories, extreme bias, hate groups on the internet, etc. So no build systems. So we are trying to identify this automatically, basically. And this is a fairly simple task for supervised learning. If you have a data set that tells you for each article if it falls into some of these categories, you can train an automated system to classify them. And there are some efforts in this area already. For example, the BS detector, which is a browser plugin that alerts users to unreliable sources. And it uses something called open sources, which is a curated list of unreliable news sources. Well, but to actually have a training set for something like this, it's a bit of a chicken and egg problem, because to identify fake news, you need something to identify fake news. And if you don't have the data, you need someone to identify all that, and the other way around. So it's a great task for machine learning. And I actually, just to show you, I downloaded about 20,000 articles altogether. Half of them, or about half of them, are identified as fake news by the BS detector. And the other half of them come from New York Times as a sort of serious publication, or as serious as possible. So I will show you a simple system that will try to distinguish these two things. So, let's have a look at it. This is just a simple function to pre-process the data, where I don't care about anything else than words. All right. And you will see that to do something like this, it's not actually very difficult. Now it's loading the data. They are rather big, so it takes a bit of time. All right. So I have about 2,000 test data and about 20,000 training data. And these articles come from 2016. All right, yeah, about 20,000 training data. These articles come from 2016, and they are basically a mix of everything from these websites. So what can we do with it? We can even use a very simple algorithm like a naive Bayes algorithm, which will look at the probability of individual words appearing in any type of article. And then we can compare for any type of article if it falls more into a fake news category or into a more serious category. Sorry, a bit of math. Naive Bayes is a probabilistic algorithm. So you basically compute a probability that something is fake given words in an article. And that's equal to probability that something is fake by default, like prior probability before seeing the actual article. And then multiplied by the probability that the words come from a fake news article. As I said, the probability of fake articles is just the proportion of fake news in my training data set. It's easy. And probability of a word in article, given that it's fake, it's basically looking at how frequent are words, is a specific word in a fake news article compared to how frequently it appears in an article that I'm trying to classify. And you compute that by basically multiplying the frequency raise it to the power of how many times a word appears in an article. So, sorry, that's a lot of mathematics. Let's see how it looks in the code. So let's see how my priors look. Well, let's compute a prior for a news type given some data. And my data are basically tuples of a type of data and the actual article. So, or I can actually, I'm interested in the average. So let's do average by. So let's have a look. So, so in my training data, I have about 40% series publications and about 60% fake news publications. So it's slightly biased towards fake news. All right. Well, another thing, if you are working with probabilities, it's much better to actually work in, because if you multiply probabilities, they are than one, so they get very, very quickly if you multiply them. But if you transfer them into log space, you can just add numeric table. So let's change this. And let's see what can we do next. Now I just want to create a collection of all words that I have in my training set. Let's move this below so that we can see. Come on. All right. So let's take all our data. And this should give me all the words I have in all the training data. So these are all the words. You can see that it's basically anything new, nothing was in emails and admits to blah, blah, blah. So how many words do we have? We have about 160,000 words. So that's quite a lot, but that's still doable. And now we can actually compute the probabilities. I'm doing this as a sort of live coding just to show you how simple it is to write something like that, because it will take me something about like 40 lines, including comments. And now I want to compute the probabilities for every news type given my data. And for that, oh, this is slightly. All right. I'll just put it here and explain what's happening there. So first of all, I'm just taking all the text that I have there. Then I'm creating a lookup table that will tell me how many times a word appears in my text. That's still fairly easy. And then I'm just going through all my words. And if I have the word in, it should have it all everywhere. If I have the word in my dictionary, then I just take number of times it appears there and take the logarithm of that, because I'm working in log space. And otherwise, I will return a small number just to account for words that are not in the dictionary, so that I don't give something a 0 probability because it contains a word that doesn't appear anywhere. And then I'm normalizing that by the length of the text. So this will give me a logarithm of probabilities of any word appearing in a fake news article or in a serious article. So feels really strange to be typing fake and not meaning fake. All right. So let's actually compute that. This will take a little bit of time, probably. Hopefully it should be a bit better now. Okay. I was thinking about just typing what I wanted to say. Then to classify any kind of word, I need to actually count how many times each word appears in a text. So I'll just change this a little. It will be just a string array. So this is an article I want to classify. And I don't need all this. I'm copying and pasting code. So I will basically just return a raw count. And that's it. So this will help me to classify any text. So right now I have basically a vector for fake news, I have a vector for serious news, and I can almost classify any new article. Right, now it should work. So how does the classification function actually look? Well, if I want to classify any article, an article is an array of strings that's normalized, which is fine. So what I need to do is get counts. Come on. How many times each word appears in an article. And then compute the probability that something comes from fake news or that something comes from serious news. So the probability that something is serious will be, I will just put together the series probabilities. And my counts. Just multiply them and sum them together. And the same for fake news. All right, so this is my likelihood that something comes from serious news or fake news, and the actual probability is proportional to this multiplied by the prior probability before seeing any data. So, and this is in log space, so it's fine, and all I need to do is that if the probability that something is serious times the prior, is larger than the same thing for fake news. Then it's serious, otherwise it's fake. And that's all. So let's try it on some word. Let's say this. Fake. The reason is that Trump appears in fake news much more, in these sorts of articles, much more than in serious articles, relatively. So let's find what's the actual accuracy on all my training data. Test data. All right. Come on. So I have a label and a text, and I want to, this will be a bit faster if I do it like this. And then to compute the actual accuracy, I want to do an average. So label and predict it, and if they are the same. All right. This should take about a minute because it's going through a lot of data, and this is not a very efficient implementation. But let's see, how good are we actually at classifying New York Times versus all sorts of fake news articles? All right. Moment of truth is coming, hopefully soon. When I was practicing this, I ran it on a training data, which took 10 times longer. And it's like, no, I can't do this in a talk. Wow. And my accuracy is 94% with such a simple algorithm that I wrote here in about 10 minutes. So 94%, that's pretty good, right? I can classify fake news articles versus serious news with 94% accuracy, so we are done, no research project needed. And I'm here in San Francisco, let's sell it to Facebook and Twitter because they have such a hard time dealing with fake news articles. And then maybe I can sponsor the next OpenF#. Well, the thing is, this is not actually answering the question we are looking at, because it's basically just distinguishing the language that these types of articles use. And something like New York Times has much more formal language than all these fake news articles. So it's just looking at that. And if you are using any vulgar words, then that's probably fake by default. If it's sort of more serious, then it might be serious as well. Well, let's have a look. If I want to classify an article that contains, let's say, Clinton will be probably overrepresented in fake news articles as well. See, fake. What's a neutral word? Well, let's try conference. Conference is serious. So it's just looking at topics and phrases that are overrepresented in fake news articles. So that's not actually helping, because it doesn't tell you anything why is it considered fake news, and if it's just an opinion piece that's very opinionated, but it's not actually falling into the fake news category. So, yeah, machine learning is only as good as your data. So the real problem is to ask the right question. And for this project, that's why we collaborate with actual social scientists. So we decided to actually look at something slightly different, not to classify news if there are actual fake news or not, or if they, based on the language, but to look at if an article mentions any sources. Because if it doesn't, then it indicates it's either an opinion piece or it might be a fake news article. Or if it mentions sources, are they named? Because then you can actually verify if they said something that the article says. Or if they are anonymous, is there a reason why they are anonymous as well? Is it because they want to protect them, or is it because someone said something and that's fake news as well? So this is the question that we decided to ask. The problem right now is how to actually get the data. Because for the previous one, it was easy to just download a lot of articles online, have them classified by something automated that has a curated list of unreliable sources. But how do we get data for this? For this, you actually, how do we get from no data to big data? Because that's what we need if we want to classify something reliably, or even if you want to train something to identify in a text, okay, this is the part that mentions a source. So how do we move to big data? Another hashtag. Well, for this, you actually have to involve humans that will go through articles and assign tags and tell you, okay, this is a fake news article. Well, not this is a fake news article. This is an article that mentions a source. This is an unsourced article. This source is anonymous, etc. So this project is sort of in progress right now. We are looking at over 300 different websites. Some of them are serious. Some of them are notoriously fake news. The problem is that the fake news websites keep disappearing and new ones keep appearing. So we have to move quickly. And my colleague is working on a crawler and extracting an actual text of an article from a website, which is quite a complex task in itself. Well, and there are a lot of students waiting, a lot of grad students waiting to actually get involved in this project and annotate articles. So the problem is that they are waiting right now, and they told me about this project like a month ago. It's like, whoa, and they are like, we need an annotator, something that will help us annotate the articles. And the money for this project are right now, and the students need to start in October. Like, whoa, that's really soon. I've never written a web app before, what should I do? Like, well, do whatever you want, we just need it. It's like, yes, I finally get an opportunity to play with the safe stack and fables. Like, yes, let's do this. As I said, we, in the research engineering group, we are generalists. So we have people that come from all sorts of different backgrounds. We have a person who actually wrote the code that basically recorded the first measurement in the Large Hadron Collider. We have a lot of people, but yeah, sometimes we just have to write a web app and no one has experience with that. Well, some people do, but they are stuck in different projects. So I was like, yes, I can play with safe. So I went on their website, got the bookstore application, that's sort of one of the examples, and hacked it together in about 3 days to actually serve as an annotator of articles. So you can see this was my first version. So you go to an article, you go through the text, and decide if the article mentions any sources or not. Simple, easy, I got to play with Fable, I got to play with Safe, I got to play with Giraffe and things like that. It was fun, good. I showed it to my collaborators, and well, that's not actually what we need. We need some much more. It is a normal thing when you are working with any kind of client, I suppose. So they were like, well, there are two really complicated things. You may want to highlight the actual portions of text that mention any sources, so that maybe later we can train a deep learning algorithm on that to actually identify these portions in the text. And we also need to ask different questions based on previous answers. Well, one of these things is relatively difficult, the other is very simple. But if you are working with a social scientist, they usually don't know which one it is. So they sent me a bunch of questions they want to include there, and they're like, well, is it going to be possible to ask a different question based on previous answers? Wow, that's just an if statement, yes. But highlighting turned out to be a bit more difficult. This is a GIF from my first version. You highlight a portion of text, that's it. Simple, but then you want to highlight more, and then you want to highlight again, and it's just not working properly. Because in JavaScript, when you highlight something, you get the selection of the text, but it gives you an index not from start of, well, it gives you an index from the start of the element you are in right now. But if you have multiple elements that you are generating dynamically, then it's relatively hard to figure out where does the highlighted text actually start, or where does it end. So this was a lot of mathematics, and I spent a lot of time with this. It wasn't working properly. So in the end, I just decided to hack it together. I just didn't have enough patience to play with indices so much. So no, let's give up. And I just overlaid two versions of the text over each other and did the highlighting in one and the user selecting text in the other, which gave me straightforward access to indices that the user actually highlighted, and it was fairly easy. So that's a big lesson, how to actually communicate complexity to a client if they don't have any idea how complex a task is. Well, of course, use blockchain for that. Sorry, I didn't use blockchain, I just wanted to have the hashtag there. We are in San Francisco, right? So, now I just wanted to show you the actual working app. Come on. All right, so this is a version of the app that I have running here right now. Because my colleague is still working on the crawler, it's a bit slow because it doesn't use a proper database yet. But let's have a look. Well, we have an article here. You can read the article. Does the article mention any sources? Yes. Let's highlight the sources, blah, blah, blah. And it works. And you can even remove highlights. Is the source named or anonymous? It's anonymous, let's say. Is there a reason for providing anonymity? Yes. Highlight the portion of the text where the reason is given, etc. So I can do a lot of highlighting. I can add another source. And this one, let's say it's named, and that's it. So it's working. And there are actually students being trained how to use it, how to correctly identify sources in the text. So I really actually enjoyed working with Fable and the whole safe stack. And one thing I enjoyed particularly is that you have shared code between the server and the client. So for example, here is my type for source information, which has a list of selections that were highlighted in the text, some IDs, etc. And I showed this to a colleague, and they're like, well, we might need to record how many minutes people actually spent annotating a source, just so that we can reward them accordingly. So yeah, that's easy, let's add it. And it's readable for people who don't know any F#, so it's great. Another thing, I showed my colleague who's working on the crawler how I'm actually generating the website. And he was like, wow, I really like these lists, so how do you do that? So he's really tempted to use SafeStack for his next web app whenever he needs to write one. So this was a big success. And another thing is, it was really fast to do. I spent 50% of my time on this over roughly a month while learning how to actually do these things. And it works. So this is a little thank you from me to, yes, it's working. So this is a little thank you from me to the community around F#, because by providing all these libraries, merging them together, providing the whole stack, giving out examples, how to actually write a real-world application with that makes everyone just so much more productive, and it made me personally very happy. So this is my little thank you to the community. And I want to say that I was talking about data science, but you might be thinking, well, I was talking to Matthias earlier, and he was like, well, so you are mentioning a safe in a data science talk, how does it fit together? Well, data science is like an iceberg, because the tip of the iceberg is the fitting of a machine learning model, which is the glamorous part that everyone sort of wants to do. But that part is basically, if you know what you are doing, that's the easiest part, because you just call a function from some library. But below water, there is a huge amount of work that needs to be done before you can do the glamorous part. So my favorite joke about data science is that in data science, you spend 90% of the time data wrangling and 10% of the time complaining about data wrangling. And it's true. But additionally, there is a lot of work sometimes to even get the data. Like in this case, we will now spend a couple of months actually collecting the data before we will see what we can do with them and what algorithms can we actually apply to them, and if it's reasonable to try to predict if a text is sourced or not. So there is a lot of work, and maybe F# doesn't have the best library support for machine learning, although it's improving all the time. But it's really great for the rest of the work. At least I appreciate it a lot. So this is my thank you to all the F# community. And I think we should all be excited about what's happening around F#. And so let's just enjoy F# for the rest of the conference. And thank you. Are there any questions? Are we doing questions? Yes, we are doing questions. Are there any? I think my daughter has a question when I'm coming back. Well, thank you then. I think there almost was a question.
Oh, there was a question.
So I guess that application looked really interesting, especially because you've done the hard work of managing the annotations and that sort of thing. Is there anything in the project that might lead to that being open source, or bits of it being extracted in the library?
For this thing, yeah, I will just, we can do basically anything, and the goal is to put everything out there. So once it's sort of in a finished state where it's actually running, I'll just probably set the GitHub settings to open, and you can play with it yourself. It would be great to actually package some of it, maybe even the highlighting, which is actually the most complex part, into some kind of library. So maybe I should do that. I should just ask for a bit more time. And to give something back to the community, it would be reasonable. Yes? Or maybe we can put it as a sample on the SAFE website.
I was wondering if you had considered the possibility that having an open source of the algorithm, people are going to just hack it for instance, given sources that don't even say what they are claiming that the sources say, or fake news pointing to fake news.
Well, that's always a problem, but I think it's a problem even if you don't open source the algorithm, because people are trying to game Google and Instagram and everything constantly. So I don't think it makes the problem much harder if we open source the algorithm. And anyway, this will probably lead to a publication where the algorithm will be anyway. So I am a big fan of just open sourcing it and putting it on GitHub. But yeah, always the danger is that it will end up as the academic GitHub that I was showing. It's basically just that no one will actually use it. But actually one of my collaborators involved in this project, Rebecca Trumbull, got a huge grant from Twitter to actually investigate the problem that Twitter has with all sorts of bots and hate accounts. So maybe we'll even involve it in that, and I think then it would really make sense to open source it.
Do you have any way to have verification that the people doing the highlighting can also, like, if someone's also looking at their information, seeing that they're doing them correctly?
Yeah, so the question is, how do we actually verify that people are sort of annotating the articles correctly? All articles will be annotated by at least 2 people. If the annotations are the same or mostly similar, then that's accepted. If not, there will be a third person that's sort of an expert annotator, one of the people who will be training the students, that will break the tie. So, and then we'll collect this into a data set, and hopefully we'll even publish the data set so that people can try their own algorithms on that. So thank you. If there are any other questions, just grab me in the corridor somewhere. Thank you.